morning, students. Welcome to the 10th session of probability. In the previous class, we started with random variables and we continued certain problems. In today's class, we will continue with few more problems on probability distribution. Okay, moving on to the third problem. Find the probability distribution of, there are two sub-questions here. Sub-question 1, number of tails in simultaneous tosses of 3 coins. Sub-question 2, number of heads in 4 tosses of a coin. Okay. Now, first and foremost, we have to find out the probability distribution of what is the random experiment in each sub-question. We have to look at that. Sub-question 1 is asking us to find out the the probability distribution of number of tails. Number of tails. What is the random experiment in the simultaneous tosses of 3 coins? So the random experiment here is simultaneous tosses of 3 coins or tossing of 3 coins. So in the experiment of tossing 3 coins, how many total number of outcomes are there? There are totally 8 outcomes. If we are denoting heads by capital H and tails by capital T, then sample space, okay, sample space S equals sample space capital S equals, we start from H, 3 heads, H, then H, T, then H, T, then H, T, then T, then T, then T, and in the end we get T and T. So we have written all the 8 outcomes of the random experiment tossing 3 coins. So we have totally 8 elements. N of S equals 8. Now look at the question. Find the probability distribution of number of tails. So the random variable on this sample space S is given to be number of tails. So we will take X, capital X as the random variable. So let X denote it as number of tails. Let X denote number of tails. So capital X is the random variable and capital X denotes number of tails. Now we have to write the probability distribution of capital X, that is number of tails. We all know that writing the probability distribution, we have 2 rows. First row is talking about the different possible values that X can take, that the random variable can take, and row number 2, that is telling us how the corresponding probability of that different possible values of X. So we will first see what are the different possible values that X can take. Okay. Now this random experiment is tossing 3 coins and random variable is number of tails. So the least possible value that X can take is 0, right? Because you can have no tails or 0 tails. That is when you get the outcome H, you have no tails or 0 tails. Then you can have X equals 1. Exactly 1 tail I can have. So that is when I get HHT or HTH or THH. Exactly 1 tail I can have. Then I can have also exactly 2 tails. That is when I get 2 tails and 1 head. That is HTT or THT or TTH. When one of these 3 outcomes come, I have the value of X to be 2, and at the max I can have 3 tails, that is T, T, T. Okay, so the different possible values that x can take are 0, 1, 2 and 3. We'll write those here. The possible values that x can take are 0, 1, 2 and 3. Only 4 possible values are there for x. X can take the value 0 or 1 or 2 or 3. Now that we have written the possible values that x can take, we have to find out the corresponding probabilities when x takes the value 0. What is the probability when x takes the value 1? What is the probability when x takes the value 2? And what is the probability when x takes the value 3? Okay, now probabilities. P when x equals 0. This denotes what? Probability when x takes the value 0. When will x take the value 0? Just now I told you, when we have no tails or 0 tails, x takes the value 0. So which are the outcomes having 0 tails or no tails? That is the outcome wherein you get 3 heads, that is H, H, H. So I can write P of x equals 0 is nothing but equal to probability of getting the outcome H, H, H. Okay, so P of x equals 0 is nothing but equal to probability of getting the outcome H, H, H. What is the probability of getting the outcome H, H, H from this sample space? How many elements are there totally? We have 8 elements. Of that, only one outcome is H, H, H. So the probability is nothing but 1 by 8. So probability when x takes the value 0 is 1 by 8. Next, probability when x takes the value 1. When will x be equal to 1? What does x denote? Number of tails. When do we exactly get one tail? Okay, when we have HHT, here we have exactly one tail. Then HTH, here again we have exactly one tail. Then THH, here again we have exactly one tail. So I can write probability of x being equal to 1 is nothing but equal to probability of getting the event HHT, comma HTH, comma THH. So probability of x being equal to 1 is nothing but probability of getting the event containing these 3 elements HHT, HTH and THH. So what is the probability of this event? Totally we have 8 outcomes. Of those we have 3 outcomes here. Hence probability of this event is nothing but 3 by 8. Okay, moving on, we have to calculate the probability when x equals 2. So P of x equals 2. What is this? When will x be equal to 2? What does x denote? It denotes number of tails. So when are we getting exactly 2 tails? When we are getting HTT, okay, then THT and TTH. Again there are 3 more outcomes, HTT, THT and TTH. So I can write P of x equals 2 equals P of set containing the elements H, TT, comma, THT, comma, TTH. So again we have event containing 3 elements. So totally we have 8 elements in the sample space. Out of them we have taken 3 elements. So probability is again equal to 3 by 8. Lastly, what is P of x equals 3? P of x equals 3. X denotes number of tails when we are getting 3 tails. When are we getting 3 tails? Only when you are getting t. So this is nothing but, I can write this as probability of t, that is nothing but equal to 1 by 8. So P of x equals 0 is 1 by 8, P of x equals 1 is 3 by 8, P of x equals 2 equals 3 by 8, P of x equals 3 is 1 by 8. Now we have found out the possible values of x. We have also found out the corresponding probabilities of the different possible values. We will write the probability distribution now. So hence the probability distribution of number of tails is, what do? We write in the first row the different possible values of x. In the second row I write the corresponding probabilities. So I denote the first row by capital X. What are the possible values x can take? 0, 1, 2, 3. So 0, 1, 2, 3. Then P of x, corresponding probabilities. Probability when x is 0 is 1 by 8. So I write it here, 1 by 8. Probability when x is 1 is 3 by 8. So we write here 3 by 8. Probability when x is 2 is again 3 by 8. So 3 by 8 here. And probability when x is 3 is 1 by 8. So we have written the probability distribution of number of tails. This is the probability distribution of number of tails. Now, if we have to verify whether the probability distribution is correct or incorrect, what do? We have to check the 2 conditions of probability distribution. Which are they? First condition is every probability must be a number in between 0 and 1. Second condition is addition of all the probabilities must be equal to 1. Now look at every probability in the second row. 1 by 8, it is a number in between 0 and 1. 3 by 8, again it is a number in between 0 and 1. 3 by 8, 1 by 8. So all 4 numbers. So these 4 numbers are numbers in between 0 and 1. First condition is satisfied. Second condition, when you add all the probabilities, it must add up to the number 1. So 1 by 8 plus 3 by 8 plus 3 by 8 plus 1 by 8. What do we get? 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 1 is 8. 8 by 8 equals 1. So you can see that this probability distribution which we have written satisfies the 2 conditions for a sequence of numbers or a system of numbers to be a probability distribution. Hence, this probability distribution is correct. Moving on, similarly, we solve sub-question number 2. What is given in sub-question number 2? We need to find out the probability distribution of number of heads in 4 tosses of a coin. Here we have to find out the probability distribution of number of heads. Number of heads is the random variable. What is the random experiment in 4 tosses of a coin? So the random experiment is tossing a coin 4 times or 4 tosses of a coin. So how many elements are there in the sample space? Totally, if we toss 4 coins, we have a total of 16 elements in the sample space. If I denote heads by capital H and tails by capital T, then we start writing the sample space. The sample space S equals, I start from H, and we start writing the remaining 15 outcomes, which is the next T, then T, T, then T, then we have TH, then we have TT, then we have TTHH, then TTHT, then TTTH, and last of all we have TTT. Okay, so I have written 16 outcomes starting from H up to T. So I will just write n of S equals 16. We have a total of 16 outcomes and I have written the sample space. Okay, now what is the random variable here? Just like the previous problem, random variable here is number of heads. So I will take capital X as the random variable. Let capital X denote number of heads. So capital X denotes number of heads. Now that we have written the sample space as well as the random variable, we have to think about the possible values of X, and once we think about the possible values that X can take, we start finding out the corresponding probabilities of the different possible values. So what are the possible values that X can take? X denotes number of heads. Number of heads can be 0, right? So number of heads can be 0. Then I can have exactly 1 head. Then 2 heads. After that 3 heads. At the max, at the most, I can only have 4 heads. So in this random experiment of tossing 4 coins or 4 tosses of a coin, at the max I can have 4 heads. In the least I can have no heads or 0 heads. So I'll write the possible values that X can take are 0, 1, 2, 3 and 4. So there are 5 possible values that X can take. They are 0, 1, 2, 3 and 4. Now that we have written the possible values that X can take, we have to start computing the probability when X equals 0, the probability when X equals 1 and so on. Okay, so the first one, P of X equals 0. So when is X being 0? What is X? X denotes number of heads. So when will we have no heads or 0 heads? When we have the outcome P of T. So I can write this as equal to P of T, which is nothing but, what is the probability of that? Totally we have 16 elements. Out of that I have taken 1 outcome. So probability is nothing but 1 by 16. Okay. Next, P of X equals 1. When do we have exactly 1 head? Well, look at the sample space. Where do we have exactly 1 head? We have to see that H, T. So this is an outcome where we are having exactly one head. Then we have THTT. This is another outcome where we have exactly one head. Then here TTHT. This is another outcome where we have exactly one head, and the last one is TTTH. So I write that P of x equals 1 equals, I can write P of HTTT, then THTT, then TTHT, then TTTH. So P of x equals 1 equals P of the event containing 4 elements HTTT, THTT, TTHT and TTTH. So what is the probability? We have 4 elements, total number of elements is 16. So it is nothing but 4 by 16. On simplifying that, I can write this as 1 by 4. So I can write it as 1 by 4. Moving on, probability when x equals 2. Probability when x equals 2, that is, I am having exactly 2 heads. The outcomes where I have exactly 2 heads. We'll see here. So which are the outcomes wherein we have exactly 2 heads? So I have HHTT. This is one outcome wherein I have exactly 2 heads. Then here HTHT, then HTTH, then THHT, then THTH, then I have TTHH. Yes, that is it. So totally I have 1, 2, 3, 4, 5, 6 outcomes. So I can write this as P of event containing the elements HHTT, HTHT, then HTTH, then THHT, then we have THTH, and in the end we have TTHH. Okay, so what is the probability? Total number of elements is 16. Of this, 6 we have taken here. Probability will be 6 by 16. On simplifying this further, I can write this as 3 by 8. Okay, so that is probability when x equals 2. Next, probability when x is 3. P of x equals 3. When do we have 3 heads? We'll have to see that here. Again, probability where we have 3 heads. Looking here, you have HHHT. This is 1. Then we have HHTH. Then we have HTHH. Then we have THHH. So these are the 4 outcomes wherein we have exactly 3 heads. We'll write those. So I can write P of x equals 3 as P of HHHT, comma HHTH, comma HTHH, and in the end THHH. So I have written the event containing 4 outcomes. So that is when x equals 3. So what is the probability? Again I have 4 by 16. On simplifying this, I can write it as 1 by 4. Last one, probability when x equals 4. Probability when x equals 4, getting 4 heads, that is nothing but HHHH. So I write it as P of HHHH, HH probability is 1 by 16. So we have found out all 5 corresponding probabilities of the different possible values of X. We will write the probability distribution now. So the probability distribution of number of heads is, so we write the possible values of X in first row. So what are the possible values of X? 0, 1, 2, 3 and 4. The corresponding probabilities we will write in row number 2. So what is probability when X is 0? It is 1 by 16. P of X equals 1 is 1 by 4. P of X equals 2 is 3 by 8. P of X equals 3 is 1 by 4. And P of X equals 4 is again 1 by 16. So we have written the probability distribution. We'll just verify. Look at the numbers in the second row. All numbers are numbers in between 0 and 1. So the first condition satisfies. But when we add, we have to get totaling to 1. So 1 plus 4 is 5. 5 plus 6 is 11. 11 plus 4 is 15. 15 plus 1 is 16. 16 by 16 gives us 1. So condition number 2 for a system of numbers to be a probability distribution also satisfies. Hence, this probability distribution is correct. Moving on to the next problem. Problem number 4. A random variable X has the following probability distribution. So the probability distribution is given here. So the possible values of X are given in row 1 and their corresponding probabilities in row 2. Then determine subquestion 1 K, then P of X less than 3, third one P of X greater than 6, and fourth one P of 0 less than X less than 3. Look at the question. We need to first of all determine the value of K. There are 2 conditions for a system of numbers to be a probability distribution. First condition is what? You have to have all the numbers in between 0 and 1. That condition is not useful for us to determine the value of K. So we'll go to the second condition. What is the second condition telling us? When you add all the probabilities, it must add up to the number 1. So we'll use that condition and try to determine the value of K. So we start the solution like this. So we know that sum of all the probabilities is equal to 1. So we have 0 plus, I'll just start as we have that. Okay, we have 0 plus K plus 2K plus 2K plus 3K plus K square plus 2K square plus 7K square plus K equals 1. So adding all the probabilities, we have to get it as equal to 1. Okay, now we will add the LHS of this equation. So we have the K square term and the K term. We'll add the K square terms. K square plus 2K square plus 7K square gives us 10K square. Now we'll add the K terms. K plus 2K, 3K plus 2K is 5K plus 3K is 8K. 8K plus K gives us plus 9K. Plus 9K equals 1. Taking this 1 on the LHS, what do we get? So we take 1 on the LHS, we get 10K square plus 9K minus 1 equals 0. 10k square plus 9k minus 1 equals 0. So this is a quadratic equation. I can have the factors as plus 10k and minus k. Okay, so 10k square plus 10k minus k minus 1 equals 0. When we multiply 10k and minus k, we get minus 10k square. When we add 10k and minus k, we get plus 9k. So I can take 10k common. I have k plus 1 minus common from next to k plus 1. So values of k are minus 1 and I have minus, so this is k equals 1 by 10. So the two values of k are k equals minus 1 and k equals 1 by 10. But what do we know from the first condition of probability distribution? No probability must be a negative number. It has to be a number in between 0 and 1. So of these two, which is the number in between 0 and 1? 1 by 10 is the number in between 0 and 1. So k equals minus 1 is not possible. We have to take the value of k as 1 by 10. So the value, so this is the first sub question, value of k is 1 by 10. Moving on, second sub question, we are asked to find p of x less than 3. So p of x less than 3. So which are the values of x less than 3? Look in the first row, values of x less than 3 are 0, 1 and 2. So I can write p of x less than 3 is nothing but p of x equals 0 plus p of x equals 1 plus p of x equals 2. P of x equals 0 plus p of x equals 1 plus p of x equals 2. Okay, what is p of x equals 0? When x is 0, what is probability? It is 0. Plus p of x equals 1. When x is 1, what is the corresponding probability? It is k. Plus p of x equals 2. Probability is 2k. K plus 2k gives us 3k. But what is value of k? 1 by 10. So this is 3 into 1 by 10, which is 3 by 10. So p of x less than 3 is 3 by 10. Moving on, third sub question, we have p of x greater than 6. P of x greater than 6. So which are the numbers, possible values greater than 6? It is when x equals 7. So I can write this as p of x equals 7. What is the probability? 7k square plus k. 7k square plus k. What is value of k? 1 by 10. We'll substitute there. We get 7 into 1 by 10 whole square plus 1 by 10. 1 by 10 whole square is 1 by 100 plus 1 by 10. 1 by 10 I can take common. So I have 7 by 10 plus 1. On taking the LCM, I get 1 by 10 into 17 by 10. Okay, on multiplying 17 by 10 and 1 by 10, we get 17 by 100. Hence, p of x greater than 6 is 17 by 100. Last sub question number 4, we have p of 0 less than x less than 3. So x is in between 0 and 3. Which are the numbers, possible values in between 0 and 3? 1 and 2. So I can write this as being equal to P of x equals 1 plus P of x equals 2. So what is the probability when x equals 1? It is k, plus when x equals 2 it is 2k. K plus 2k gives us 3k. Value of k is 1 by 10. 3 into 1 by 10 gives us 3 by 10. Moving on to the next problem. Problem number 5 states that the random variable x has a probability distribution p of x of the following form, where k is some number. So if p of x is given, p of x equals k if x equals 0, 2k if x equals 1, 3k if x equals 2, 0 otherwise. Subquestion 1, determine value of k. Subquestion 2, find p of x less than 2, p of x less than or equal to 2, and p of x greater than or equal to 2. First and foremost, we'll write this probability distribution in tabular form. So we'll start here. Solution. The probability distribution of x is, we'll write x. So the possible values that x can take are 0, 1 and 2. 0, 1 and 2. Corresponding probabilities. When x is 0, corresponding probabilities. P of x is k when x is 0. When x is 1, it is 2k. When x is 2, it is 3k. Okay, now that we have written the probability distribution in tabular form, we will start to find out the first question, that is determine value of k. Again, just like the previous problem, the first condition of probability is that every probability must be a number in between 0 and 1. That will not help us to find out value of k. So we'll use the second condition, that is when you add all the probabilities, it must add up to the number 1. So we have adding all the three probabilities, k plus 2k plus 3k. What does it give us? 2k plus 3k is 5k. 5k plus k gives us 6k, or I will write that as equal to 1. So LHS 6k equals 1. So what is value of k from this? Value of k is 1 by 6. So we have determined the value of k to be 1 by 6. Now look at subquestion B. What is the first question in subquestion B? P of x less than 2. So P of x less than 2. Look at the probability distribution. Which are the possible values less than 2? 0 and 1. So I can write P of x less than 2 is nothing but P of x equals 0 plus P of x equals 1. So what is the probability when x equals 0? It is k. What is the probability when x is 1? It is 2k. K plus 2k gives us 3k. Value of k, we determine it to be 1 by 6. So we get 3 into 1 by 6, which is nothing but 1 by 2. Okay. Next, P of x less than or equal to 2. P of x less than or equal to 2. It is nothing but P when x equals 0 plus P when x equals 1 plus P when x equals 2. P when x equals 0 plus P when x equals 1 plus P when x equals 2. Okay, what do we get? We get k plus 2k plus 3k. So that gives us again 6k. Value of k is 1 by 6. So 6 into 1 by 6 gives us 1. Looking at the last question, P of x greater than or equal to 2. P of x greater than or equal to 2. So I can write this as P of x equals 2 plus P of x strictly greater than 2. So there are two conditions here. P of x greater than or equal to 2 is nothing but P of x equal to 2 plus P of x greater than 2. But what is P of x being equal to 2? It is 3k. It is 3k plus what is P when x greater than 2? Look at the definition. Otherwise, when x takes the value 0, 1 and 2, we have to use these three probabilities. When it is other than these three values, then the probability is 0. So P of x greater than 2, I will take it as 0. Then this is nothing but 3k plus 0 is 3k. Value of k is 1 by 6. So we get 3 into 1 by 6. On simplifying that further, we get it to be 1 by 2. So that is the end of probability. We'll meet in the next session. Thank you.